All right, here we go. We're going to take a look at 9.4b. There's two things that we're going to cover right here in 9.4b. The first one is horizontal and vertical transformation, and then the second thing is reflection across the midline. From our student journal, as you can see on the screen, we have the standard form of a graph of a sine and cosine function. It's very similar to that of like a parabola. Remember, a parabola started off as y is equal to a times, and then parentheses x minus h, quantity squared, plus k. And the x minus h, or the h part, uh, dealt with our horizontal shift. The k had a vertical shift of the parabola. So for our sine graph, the h is the horizontal, the k represents the vertical. Uh, Several things when you're going to graph these, you're still going to have to find the amplitude, then find the period, and then we want to know what h and k is so that at the end we can go ahead and move that function around. We also need to draw the midline. I'd probably do that right even before we graph anything else, and then we'll go ahead and make sure we have our 5 points to fully and show the transformation. You're probably going to have to graph things twice. You're going to want to draw the original graph and then the horizontal shift uh, after that. Or at least let's set up where the midline is, and then from there we'll draw our function, and then lastly we'll shift the points that we put down left or right depending on which way it's going to transform. So next up on our examples right here is this equation: y is equal to sine 1/2 times x minus pi plus 1. As we take a look at things, I have below our equation so that we can kind of help us better determine where's A, where's B, and our horizontal and vertical transformation. Hopefully looking at this, we have x minus pi. This minus pi does not mean our sine graph is going to move to the left. It's actually going to be opposite, and it's going to move and shift everything to the right. The A term right here, in front of the sine, there's nothing there, so that means A is equal to 1. B right here, right after the sine, it is 1/2. All right, so we've got pretty much those are the main things that we need to make sure we worry about. H is pi, that's how much it is shifting to the right, and then we also have K as well. And then we'll take a look at all that. So finding the amplitude, pretty simple. Absolute value of 1 is 1. So that is our amplitude. For our period, we have 2 pi divided by 1 over 2, or absolute value of 1 over 2. And right here, remember, when we divide a fraction, multiply by the reciprocal. So 2 pi, you're going to end up multiplying it by 2 over 1, or 2. So our period right here is 4 pi. Things are being stretched out. And then our midline is y is equal to k. And let's go ahead and put right here y is equal to 1. So now we have all these main things. Let me go ahead and make sure we circle this minus pi right here so that we know that we are going to deal with the horizontal shift. So to start off with, let's draw the midline first. Let's right here. Each of these intervals will represent 1 unit. Right here at the origin, that's 0. And then we have -1. Down 2 more, it's -2. So this is pretty much, let's go ahead and roll with that for our intervals. We always need to, after that, we need to go ahead and come up with our points. And I'll go ahead and mark up the x-axis right here. And remember, we always split things up into quarters when it comes to sine and cosine functions. So from the origin all the way out to this hash mark, that will represent our period of 4 pi. And I'll go ahead and put that down right there. And then to find the rest of our intervals, remember the first hash mark will represent 1/4. So if I take 1/4 of 4 pi, that will get us pi. This is the halfway mark, so if I take 1/2 of 4 pi, we've got 2 pi. And then right here, if I take 3/4 and I multiply it by 4 pi, then you're left with 3 pi. Our intervals are going to work out perfectly for our when we go ahead and transform our graph right here. So now that we have that, let's take our midline. And our midline is going to be y is equal to 1. So I'm going to go ahead and draw a horizontal line right here, going through 1. So there's our midline. Next up, let's think to ourselves, okay, sine function, it always starts at the origin, or now you're going to know that it starts right here at the midline. So let's go ahead and I will put my first point right here at 0, 1, and then from there it goes up to pi, comma 2. It reaches the maximum, and then it's going to go down right here to 2 pi, continues its way down to the minimum, which we have at 3 pi, and then it will go back up right here to 4 pi. So we have ourselves our first period for our function. All right, so we are almost done, not quite yet, because you got to remember that everything is supposed to shift right here to the right by an amount of pi. Well, remember earlier I said, hey, this is going to work out nicely because each quarter right here happens to be an interval of pi. So what I'm going to go ahead now is let's start at 0, 1. That point, if we move that point to the right by pi units, that first point now will be moved over and it's going to be at pi, comma 1. Let's go to next, the point that is right here at pi, comma 2. We're going to move that to the right, and there you go. That's where that point will now be, moving it to the right, pi units. We have this point right here at 2 pi, comma 1. We'll move that over to the right, pi units, and now we're at 3 pi. And then right here, the point that was at 3 pi will now move over and shift to 4 pi. So let's go ahead and we could take the one that's at 4 pi, it'll move over here. So I'll go ahead and draw this out. And now you can see that all these points got shifted over by pi units. If we were to continue the graph now, right here, let's say we go this direction. Remember, this is the midpoint or the midline at pi 1. If we go the opposite direction, it's going to be going down right here, and it's at 0, 0. And then that's at the minimum, so it's going to have to go back up right there. And so this would technically be negative pi, and then there's your function. Okay. And so you can see that the function has been shifted over to the right. As we take a look at all the points and compare them, it has moved over pi units. Let's take a look at our next example. So this time we'll deal with our cosine function. We'll do the exact same things as what we've been doing and taking a look at. And so let's start off. A is equal to 1. B this time is also equal to 1. And then we have ourselves h as pi over 2 and k is negative 3. This time right here with this pi over 2 or plus pi over 2, that means it is not going to the right, but this time our function is shifting to the left, pi over 2 units. So let's go ahead right here. Amplitude is A is equal to absolute value of A, which is absolute value of 1. And then for our period, we're going to go ahead and this will be at 2 pi, right? Because 2 pi over 1, because B is 1. Our midline, this time happens to be y is equal to negative 3. So let's, next up, let me go ahead and put our intervals. We'll have negative 1 right here. Go down 2 more, negative 2. We got negative 3. And right here, negative 4. Our midline is at y is equal to negative 3. So I'll go ahead, draw a horizontal line going through negative 3 right there, and that is my midline. Let's, next up, we'll figure out our rest of our points. We'll cut this up into quarters, and then right here at the fourth, or actually the fifth point, but at the fourth hash mark, this right here ends up being 2 pi. We have 1/4 of 2 pi that goes right here. Okay, we take ourselves 2 pi times 1/4, then that becomes pi over 2. All right, next up we take 1/2 of 2 pi, and that gets us right here. We're left with pi, and then when we take 3/4 of 2 pi, we're left with 3 pi over 2. So it works out nicely once again because 1 unit over is pi over 2. So if we shift everything over to the left, this time pi over 2 units, it's actually shifting it over 1 unit. Right? This right here going to the left is actually going to be negative pi over 2. We have ourselves negative pi, negative 3 pi over 2, and then negative 2 pi. So now that we have that, we've got our amplitude, and think about this. Remember, in a cosine function, the graph always starts above the midline. So I'm going to go ahead and draw the original function without the horizontal transformation or the horizontal shift. And so right here, first point will be up at 0, negative 2. And then it will be over here at, it's at the maximum. It's going to go down to pi over 2, comma negative 3. Then we go ahead, our next point will be at pi, negative 4. We'll move this, it reached the bottom. It's going to go back up to 3 pi over 2, negative 3, and then continue its way up to the maximum at 2 pi, comma, negative 2. All right, so there are our points right here. And ahead and extend it out to the left side. This right here is our original function. And so what we want to do is this now, we want to go ahead and shift this horizontally, pi over 2 units, and this time it's going to the left. So if we start right here at, let's say, at 0, -2, if it's going to shift pi over 2 units going to the left, this point right here will now end up being at -pi over 2, comma 2. We have this point right here at -pi over 2, -3. It will be shifted over to the left, right there, pi over 2 units. And so we'll go ahead and let's do that with all of our points. Let's move it over. We'll shift this over here. This point at 3 pi over 2, we'll move that over. And so our graph right here in green is now displayed as the actual graph of our horizontal and vertical shift. Okay. On your homework, you're going to want to make sure you do both. Okay. It'll be helpful because then you're not guessing and trying to figure out, all right, where are the points supposed to be? Draw the first graph. It's good practice for you. And then move the points left or right depending on the problem. Okay. For the last one right here, we're going to look at reflection across the midline. And so we have another problem where we're going to have both some horizontal, actually there's no horizontal shifting, we just have some vertical shift. So let's go ahead and put this all together. You're going to have to draw once again 2 graphs right here. Draw the original and then draw the original with all the horizontal vertical shifting, the transformations, and then after that I'll show you what to do to get the actual function for the reflection. So right here, let's go ahead. We should know that A is equal to -2, B is equal to 4. Remember, parentheses, x minus h. Right here, if there's parentheses, then I would say that there is a horizontal shift. But there is no horizontal shift. We have this right here, -1, and that is actually representation of k. And that is our vertical shift. So, a little tricky, a little bit different. All right, so you might see that in your homework problems later on. And right here, let's go ahead, our amplitude value -2 is 2. For our period, we take ourselves 2 pi over 4. So we get ourselves pi over 2 is the period. Our midline right here is y is equal to -1. Let's go ahead and mark up our axis. This will be 1, 2, 3. And let's have -1, -2, -3, -4. Our midline is y is equal to -1. So here's my horizontal line going through -1. And because our amplitude is 2, we'll have an idea of, it's going to go up 2 units, down 2 units. So our maximum is up at 1 for y and -3 for y as well. We have our shift. Let's go ahead and label our x-axis right here. So we are splitting it up into quarters, and the fourth one right here happens to be pi over 2. So things are a lot smaller. Everything's actually being squished if you were to put it into Desmos and compare it to uh, our normal period of 2 pi. And so remember, to get the first part right here, we take ourselves, we've got 1/4 times pi over 2. All right, so this is actually pi over 8. The next one right there is 1/2. So if I take 1/2 times pi over 2, we have right here, this is pi over 4. And then we have right here, this 3/4 mark, so 3/4 times pi over 2. And this will be 3 pi over 8. All right, so that will represent all of our 5 points, including right here at 0, 0. And I'm going to actually, let's move this stuff up and move it out of the way. So typically our cosine function right here starts at the midline, but it's not there. It is going to be up at the maximum above it. And so our amplitude is 2, so at 1, go up 2 units. So right here at 0, 1, that is the first point. From there it goes down, so it's going to go down right here. At pi over 8, negative 1. It will continue to work its way downward. And you can see things are stretched out a lot more than some of our other problems because it's actually 2 units. It reached the maximum, so it's going to go back up right here and then continue to go back up. And there is our function. And let's go ahead and draw out a little bit more right here, left and right. Now what we actually drew is our function without the reflection. Okay, so the reflection is the inverse, right? So what we're going to do for the final part is, all right, we're going to take every single point right here and reflect it across our midline. So this point right here that's at 0, 1, we're going to go ahead and reflect it across this line, and that will be down here at 0, negative 3. This point right here that's actually on the midline will stay there. Okay, so that'll stay right there. This point down at pi over 4, negative 3, when we reflect it across the midline, it will be all the way up here. This point will remain the same, the one at 3 pi over 8. And then this point right here at pi over 2, 1, it will be all the way reflected across, and it will now be down here. So our function will look something like this right here. And that is how you draw your reflection. So the actual graph is the one that you see right here in green. And there you go. You now know how to reflect and shift these graphs horizontally and vertically.